Hey everybody, it's Nick. Today's tutorial is about computational strategies. This is a powerful idea that applies to almost any software or any kind of digital device that you might use. And this idea comes from the fact that all computer software and digital machines are computational, like at their core. They have certain characteristics, they're logical, they operate on data, they can work repetitively, and what we can do is we can exploit those like attributes to work better. And what I mean by working better is to be more efficient and more effective. That is to say that we can do things in less time. We're more efficient, and we can make more things, or we can make things more intelligent, so that it's easier to make changes. It's easier to make copies of things, make variations of things. That can help us be creative. Of course, at the same time, if we take less time to do things, that can also help us be more creative because we can make more things, or we have more time to think, or we have more time to rest. And so it's a really good idea to understand these computational strategies and to look for them in any software or any kind of device you're using because that's a way to help you work better. And I'm going to show you in this video the fundamental computational strategies. And as I do this, I'm going to explain how they work and how they help us work better. Again, almost every piece of software that we use, whether it's Photoshop or Rhino or Revit, can make use of these strategies. And to prove it, I'm going to demonstrate them in a piece of software that all of us probably use, but we hardly think of as powerful or computational. And that's Microsoft Word. Um, so to like start off, the first strategy that we want to talk about is something that I always talk about in my classes, and that's that it's free to make a like digital copy of something, right? It doesn't cost anything. You don't have to make another one. It's as easy as copying and pasting. So that's the first thing I want you guys to think about is the idea that in a computational system, copying objects is really powerful. And so to do that, I might take something, and I might take this. This is a Word document that let's say I'm working on some fake text here, but it's very easy to make a new section head just by like copying and pasting it, right? And that's already like a really powerful operation. I can go in and I can make these copies here and say that's a subsection, that's a subsection, and it's really easy. And that's a very simple example, but I just want you guys to think about that. The other thing that I want you to think about is that when you're making a copy, it's a really useful thing to like modify the exceptions. So you make all your copies, and then you might have one thing that you change, right? And so like I might be making all these copies, and I made all these copies that say subsection, and they say, oh wait a minute, that's actually a new section, so this is a section. So again, it's a way. So instead of like writing each one, or instead of copying and pasting that one into there, it's easier just to make all the copies you're gonna make, and then go back and modify the one that's different. And that's gonna be faster. It's gonna be less error prone than again just simply copying and pasting, or copying and pasting one into the other. So always look for that where you've maybe got one thing or two things that's different out of a large group of things, and like look for that structure. Because even though copies are cheap, you also don't want to make too many copies, right? And so looking for the exclusions is a really important thing. So yeah, so we've got that. So we've got a section, and the other thing that I want to talk about is that when you're working with files, things you're working on, whether it's a Word file or whether it's like a Revit file or a Rhino file or a Photoshop file, is the idea that you're working on a data structure, right? The file is data. It's organized differently, whatever, but it could be points or lines or numbers or all those things at the same time. I don't know if you guys think about this, but Word is what's known as a word processor, right? You can process like language, process information, and one of the key ways to think about to expose that data structure of a program like Word, so we could do something like I can look for the word, robot. I can say, there's the word robot in there, and that's way easier than reading through everything and trying to find it. We all know from tools like Google how powerful like search is, and we can actually filter the objects that we're working on based on some criteria, to quickly find the thing we're looking for rather than actually looking for it. And this is really important as objects get larger or Photoshop files get bigger or InDesign files get bigger, is to think about ways that we can filter that information and we can find things we need. The other thing that is important to note is that if we're working on a data structure, we can use that to quickly change things that are filtered. So if I look for the word computer in here, I have lots of different words that show up that I've used the word computer. But what if I wanted to like change that? What if I'm not interested in robots anymore? I'm not interested in computers anymore. I'm interested in computers. I can go to replace, and I can say look for computer, replace it with robot, and I can say replace all. So we have processed that document. We have word processed that document, right? We've changed the data structure, and all instances of computer have been changed to robot. And this is useful if you misspell something or if you want to change something. But in like a design, if you have a new part that you need to replace it, if you go in and try to manually replace that part, you're bound to make a mistake. But if you filter the data structure and you select those objects that meet your criteria and you replace them with the thing automatically, you're less likely to make a mistake. And that's extremely useful. Like, it's time saving, less errors, less things to fix. The only problem is you have to really pay attention to what you're doing, because you could inadvertently change something. So there might be another thing where, just in the way that I've been looking, I can say, oh, wait a minute, I want to change that robot back to computer. Again, find the exception in there, right? But if you have the data structure, it makes it so much easier to filter information and change it. So that's really powerful. So another thing that's really powerful about computers is the idea of dependencies. And dependency just means that there's a relationship between an object and another object. And that could be a variable, like an actual number. It could be something like a color or some kind of attribute. But the idea is that within the structure, there's actually relationships, right? That the data is not just like isolated. And you can exploit those relationships to really quickly make changes to things without making mistakes. You can make interesting copies of things, but it makes your work a lot smarter to work that way. And you guys have all heard of the term parametric, I'm sure, like parametric architecture or parametric design. A parameter can be something like a color, or it could be like a size. And this idea of dependencies is very close to the idea of parametric design. And as an example of that, I'm going to go through styles in Word. And I'm not sure how many of you use styles when you're using a Word document. But it's this really powerful idea. Usually by default, everything in the document comes in under the style normal. And that's what things are by default. So I can go in and I can right-click this and go modify. And if I want to, I can go in and change this style, and I can make everything Helvetica new. And that's going to make everything like Helvetica. I can go in and change it to a smaller font if I want to. And that propagates that change. Everywhere that there's like a dependency created, it's going to make that change for me. Instead of me going in and selecting everything and changing the size here. You can do it with the style. This should look familiar to you. It should be what we talked about when we did InDesign, right? That you have character styles or paragraph styles or things like that. That's exactly the same idea. The other thing that's interesting about it is that you can also use the styles to organize the document. So, for example, you have a style called title. Title makes it big, and I can go in and I can go back to Helvetica, bold, make that new. And then I can go into my sections here. So each of these could be a heading. Right, so that's a new section. It's a new section. And subsections will be heading 2. And that's what those mean, if you ever thought about that. There's heading 2. Heading 1, and you get heading 3, and everything kind of goes on from there. And it's really powerful, to go in and make those relationships. So I can say, well, I want these to be black. See, it's already made the change there. Go into heading 2. And once you set this up, it's in the document. You don't have to do this every time. All you got to do is just say heading 1, heading 2. If you had a document that was already set up this way and you started with it, all those relationships are already set up too. And this is really useful. A lot of organizations like have this kind of stuff, right? So you have sections, subsections, sections, subsections. And why that's interesting is if you go into the navigation panel, which is under view, and you can go sidebar navigation if it's not already up, and you can actually go ahead and skip to different sections. And I could say something like, this is subsection number one, subsection number two, and of course it updates it automatically. And if you get a bigger document, you can actually open and close these. And this is another idea about filtering information, right, at different states of information. So just in the way that we've got layers and other things, we can use the organizations that we create through the styles as a way to filter information in our file. So we can turn things off and on. We can hide things. We can like open them up. But that's a way to use that. So there's a correlation between the dependencies that we create and the information that we're allowed to filter. So that's kind of powerful too. And of course, like again, there's a bidirectional relationship between the dependencies. So on one hand, if I change this, I can change this here, and then I can right click it or up here, and I can say update heading 2. So now all the headings change. I can also go up here and change it, and that change is going to propagate to all those. So the more you get into the habit of organizing your files and creating those structures and manipulating them, it's going to make things a lot faster for you as a designer, and a lot easier for other people. Like if someone else has their file, it's going to be easy to make those changes using the styles that you already have set up. Okay, so there's that, and so then another thing you can do is there are things that are built into a lot of programs like wizards and widgets and things that are already organized, and you want to try to exploit those whenever possible because they can make your job a lot easier. So if I look at this file that I made, a lot of people use computers to make lists of things, and they even use spreadsheets like their lists, and that's not really a very effective way to work, especially if you need to make changes. If you look at this right now, you can see that it's a simple list of a class, and it has a number of students, and then there's like a total, and that's fine if you're never going to change it. But it's not really easy to format. It's not really easy to change or like propagate those changes. And so what you'd really want to do is go ahead and use something like the built-in spreadsheet that's in Word. So you can go in and you could say, insert table. Okay. And then once your table is actually formatted, let me give yourself some room here. You can do a lot of different things. Like I can go in and I can actually, if I go into, now that it recognizes that that's a table, I can insert a row. I can go to formula and I can create a total. So it becomes very easy to do things like, and if I had a different, calculation, I can go in, and this works a little bit differently than the way a spreadsheet works in Excel. You actually have to update things manually, which is kind of a pain. But I could do things like if I choose this, I can say like an auto fit the contents. Makes it very easy to save space. I can go in and I can change the style of it if I want to. So I can go in and make it pretty. And again, it's easy to change the format of it. Like I can change the size of it if I need to. I can change the spacing of it if I want to. There's not a lot of it's not easy to do that with just the information that I have there. It's not very smart. It doesn't know that it's a table. It doesn't know that I'm looking at like information. And so it seems really simplistic, but it'll save you a lot of time if you can use these things. So for example, if you're making something in Photoshop, instead of just throwing on a filter, you might want to use like an adjustment layer, right? Because that lets you actually change things later, as opposed to fixing those changes permanently. So making those organizations, known, and then making use of those organizations that are built into the computer is a really good time-saving device. And there's lots of examples of this that we'll talk about, later. The last example is one of the most powerful. One of the things I like about computers is that it's really an easy way to automate a task that's repetitive. So, for example, let's say that I'm going to let people like into the program, and I've got a spreadsheet that's got. Hang on one second here. There we go. It's got the names of the folks that have been accepted. So I go in and I'm gonna take the name, copy paste it into here. She's an architecture. And I could do that, especially if I have like a lot of students. That's going to take me a lot of time. It's going to be very easy for me to make mistakes. I got to send it out to the email address, and if you think about it, again, the Word file is a data structure, and I've got data here, and I'm just doing the same thing, over and over and over again. Go in, change the name, go in, put the major in, write the email, and all this takes a lot of time. And again, I can be making mistakes, and then I might tell Tom that he's been accepted to interior design by mistake, or Sue got into architecture, and then someone's angry at me. And it's just boring, and it's something I don't really need to be, doing. Like, I could exploit, the power of the data structure and the fact that the computer can repeat a task like over and over and over again, and it's not going to be bothered at all. So what you can do in various tools have different structures for automating. Word happens to have something called mail merge. So you can go to mail, and I can say start mail merge, and I can make an email message. And then I can go in and say select, and I'm going to use a list. And the list that I have is my data set. It's fine. Okay, and then I can go in and I click on the thing, and I can say insert field, and I can say student name, major. It's going to be major, and maybe a space there. And then if I say preview, I can say it's Liz, Tom, Sue, Betty, Frank, Bob, and I can finish that, and I can actually email them if I put in the email address. I'm not going to accidentally email a bunch of things to Iowa State, but you can see this isn't just about eliminating like drudgery. A lot of things like scripting and controlling robots and digital fabrication are about like automating these things. Taking data from your cut file and creating a set of points is something that you could do manually, but it's way easier to do it with some software, with a script or with an automated thing. And that's again what's really powerful about it. Anyway, so all these are examples of computational strategies, and they're found in like any piece of software, right? So going back through really quickly, lost my file there. Here we go. The idea that you can make like copies of things, right? The idea that it's very easy to like copy paste, something. Making copies, making changes to the exceptions in copies, the idea of filtering and searching, right? And finding and replacing things, right? Very, very powerful thing. The idea of creating and modifying dependencies for things. Using like organizations in the computer to make things faster and more efficient and more intelligent. If I go in here. Yep. I wish this was a little bit more intelligent. Maybe I can figure out a way to do that. Anyway. And then going, another thing is, being able to filter. Sometimes you can accidentally create a style that's a blank. You don't really want to do that. But the idea that you can filter information. Probably should have been this. This is a new section. But that makes that very, very intelligent. And then lastly, the ability to automate like repetitive tasks, is really powerful as well. So all those things can be found in almost any software, any device you use, and I would be interested in hearing where you find those things in your various softwares. I think that's a task we can all think about. They aren't necessarily called these things, but this is a language that we can use to talk about computation and talk about computational strategies. And as you're working, I want you to think about where these things might show up and how you can make use of them. You have to be mindful that they're there, and you have to take steps to use them. Otherwise, it's very easy to do things manually. Copy paste things, like make a list, change things manually. But if you do that, you're not taking advantage of the computation. You're bound to make problems. Things are going to take longer. You're going to make less stuff. So I want everybody to be thinking about these things, and I'm going to keep bringing them up when they show up. And I want you to bring them up, and I want you to be thinking about them. And we'll stop there. Okay? So thanks very much.